Question 6. Joe is researching a red giant star that's approximately the same mass as the Sun. Joe knows that the surface temperature of the red giant is approximately 3,400 Kelvin. What is this temperature in degrees C? Well, to convert from Kelvin to degrees C, you need to subtract 273 from the Kelvin temperature to get the temperature in degrees C. So this would be 3,400, take away 273, gives us 3,127 degrees C. Part B. In a red giant, the main source of energy is the fusion of helium nuclei in the core. Explain how this shows that the core temperature of the red giant must be higher than the core temperature of the Sun. Well, to answer this, we need to think about what happens inside the Sun. In the core of the Sun, hydrogen fuses. Helium can't fuse in the Sun because it requires more energy. Think about it in terms of the charges. Helium has 2 positive charges, 2 protons. Hydrogen has only 1. So you need more energy to overcome the electrostatic repulsion. So the higher temperatures in the red giant core provide enough energy for helium fusion. Part C. Which of the following elements are not produced by fusion in this low-mass red giant? Let's look down the list. First of all, you cannot create hydrogen through fusion. Hydrogen is the simplest possible atom. It only has 1 proton, so you can't combine 2 other elements together to create hydrogen. So hydrogen is definitely not produced in this red giant. Looking down the list, the next element that should jump out is iron. Iron cannot be formed inside a red giant. In fact, iron and all of the elements heavier than iron can only be produced in supernovae, which are incredibly hot explosions of supergiants. They certainly cannot be created in the core of any star or red giant. Part D. What is likely to be the next stage in the life of this low-mass red giant? Well, it's been stressed that this is a low-mass red giant. It's not a supergiant, it is a red giant. And the next thing to happen to a red giant is that it will become a white dwarf.